brother. We have another question to solve today. And the question we are solving today is on the integration by parts. But before I proceed with the solution, I want you people to watch and subscribe to my YouTube channel. I want you to watch and subscribe to my YouTube channel. Don't just watch alone, watch and subscribe. Honestly, I need your subscription. So try as much as possible to watch and subscribe to my YouTube channel. You can share and like my video. I will appreciate if you can do all this for me. Now let's go solving the question on the board. We have a question on the board. We have evaluate integral x squared plus x dx. This aspect of integration is under integration by parts. And for us to solve integration by part, a formula will come onto your mind, and that formula is we're going to have integral u. We're going to have integral u dv to be equal to uv minus v du integral. This is the formula of integration by parts. We have integral u dv to be equal to uv minus v du. How do we know the one that we are going to use? As in, if you look at this question now, you will notice that we can split this question into two. We have x squared, which is an algebra, and we also have cos x, which is trigonometry. One of them must be assigned with this letter u, and the other one we have dv. How do we know the one that will be given u and the one that will be given dv? Then we are going to consider outlets. Arclet. This arc means arc as in inverse, tan inverse, sine inverse. We have L for lean, we have A for algebra, we have E for exponential, and we have T for trigonometry. This is how the arrangement is. The one, we are going to check the one that comes first. If you relate this question that we have here with this, you will notice that algebra is the first here, and algebra comes before trigonometry. So when you want to solve this now, our u will be equal to x squared because algebra comes before trigonometry. Then we have our dv to be equal to cos x dx. That is that for that. Then the next thing we are going to do now is to differentiate our u. Then we are going to integrate our dv. If we differentiate our u now, we are going to have our du. That will give us 2x. And when you integrate dv, you will have our v now. When you integrate dv, you have v. And that will give us sine x. Now, we will need to go back to this formula here. From the formula, we have integral u dv is equal to uv minus v du. Then we can now use this formula. Going with the formula, we will have uv. That will give us x squared sine x as in uv. Then minus integral. We are going to have v du. This is our v. This is our du. That means we are going to have 2x sine x dx. But you need to move the constant to the back of the integral sign. When you move the constant to the back of the integral sign, you have x squared sine x minus 2 integral x sine x dx. As you can see, this equation we have here, this one that we have here, is now like the original question that we have. So we need to move this one out of this equation and solve it on our own. But before I do that, I can call this equation, this line here, I can call this one asterisk. Big equation asterisk, because I need to first simplify this. After simplifying this now, the answer I have to move the answer back to this equation. So from here now, I have integral x sine x dx. From here, I can have my u to be x. Then I'm going to have my dv to be sine x dx. Then from here, differentiate u. Now you have the u is equal to 1. When you differentiate x, you have 1. Then integrate dv, you're going to have minus cos x. So when we now use this formula now to get an answer, we are going to have, we have uv, that is the first one, uv. So we have uv will now give us minus x cos x. uv minus integral v du. Our v is this, then our u is this. We are going to have minus cos x dx. So from here now, you will notice that we can differentiate, we can integrate this minus cos x. Or before we integrate, we are going to have our integral x sine x dx to be equal to minus, we are going to have this to be equal to minus x cos x. Minus times minus will give us plus integral cos x dx. So from here, if you integrate this cos x, we are going to have our sine x back. So this one now will now give us minus x cos x, then plus integrate this one, we are going to have sine x. So from here now, we have gotten an answer for this. We can now go back to this equation asterisk and substitute the value here into that equation asterisk. If you substitute that one into that equation asterisk, we are going to have minus, we are going to have x squared, as in this, sine x minus 2 into minus x cos x plus sine x. Then we can now open the bracket. If you open the bracket, you have x squared sine x minus minus will give us plus 2x cos x minus 2 sine x. Then so our integral now we have, if we now integrate x squared cos x dx, the answer you will have now will now be x squared sine x plus 2x cos x. Then we are going to have minus 2 sine x. Then we are going to attach plus c. That is the answer that we are going to have. So whenever you are solving any question on the integration by part, you have to be very, very careful. Follow the rule of integration by part. And also, you try and be very, very careful so that you don't derail. As you can see, we have come to the end of this particular solution. In our subsequent episode, we are going to take it up from here. But please don't forget to subscribe, watch and subscribe to my YouTube channel, Akeem Ola. I will appreciate if you can do this for me. Thank you and God bless. This one.